Assalamu alaikum everyone. I hope you guys are doing great. So in this video, we are going to talk about again the log function, but this time around it's a bit different. It's the fourth section. We'll be talking about equations and inequalities using logs. So let me just write down the heading first. Equations and inequalities using logarithms. Okay, so let's get started. Okay, now here basically some of the equations would be having logs in them and we will be solving it. When we say solving an equation, it basically means we need to find the value of the unknown variable. And for some of the cases, we would not be having any log initially, but in order to solve the equation, we would be just making the log by taking it on both sides. So everything would get clear once we talk about a few examples. Let's talk about example number 1. Solve the equation four power x equals 16 by taking logarithms on both sides. Now, obviously, this is given because it's an example. If this question would come in exam, you guys are supposed to do it directly. Okay. Now we have two ways of doing it. Let's talk about both the methods and then it would get clear. Method number 1, and then I'll be doing it through method number 2. Okay, if I talk about method 1, it is 4 power x equals 16, and I know that I can certainly write down 16 in terms of 4. I know 4 multiplied by 4 is 16, so I can actually write it as 4 power x equals 4 squared. And what do I see? I have two bases. Both the bases are equal. This expression is equal. This certainly means that these two powers are also equal. So this means x is equal to 2 and this is going to be your answer. Now method 1 worked this time around because I was able to write 16 in terms of 4. I was able to do that. But what if you are in a situation where you can't write the other number in terms of the first number? How do we deal with such cases? For that, we need to apply the log method. Okay, now what is the log method? We know that log is basically used this way. Now imagine, let me just write down the equation first. So we again had 4 power x equals 16. Now when I will take log on both sides, this would become log 4x equals log 16. When I'm not writing down the base, it means that the base is 10 for both of them. Okay, and then what I can do is I can just write it down this way. I can write this x over here. Whatever I have in the power of a number can be written before it, so it would become x log 4 equals log 16. Now I can write it down this way. X equals log 16 divided by log 4, and we discussed some properties for logs, and we know that whenever we have two logs which are being divided, we can actually write it other way around. I can write it this way. Log 16 can be written as 4 squared, and then this is divided by log 4, and now I can again take this 2 over here, so it would become 2 log 4 and I can write it as 2 log 4 divided by log 4. Log and log is cancelled and I'm left with 2. That is the answer. Now certainly this method 1 was simpler than method 2, but method 1 would not work every time. Method 2 is going to work every time. So now you know, whenever we have questions where the unknown is in the power, where the variable is in the power, we can just apply log on both sides and then simplify things. We know that log has one of these properties that if I have log 4 power x, the power comes over here. And then I can just simplify this. I've used some further log properties. I've written log 16 as log 4 squared. And again, I had this 2 in the power. So I've written that over here, and I was left with log 4, and they got cancelled, and the answer again was 2. So this way or the other, the answer is going to be 2. The method would depend upon the number of marks the question has and upon the numbers we have in the question, and that is how it is. Okay. All right. Let's talk about some more examples to be clear, to understand the concept very well. Okay. All right. So let's talk about example number 2. Now, example number 2 says, solve the equation 5 power x equals 3 power 2x plus 1. Okay. Now another scenario, and this time around it clearly means you need to use log. Now I can't write 5 or 3 in terms of 5 or 3. I need to incorporate log here, and then things would become easy for me. So let's talk about the solution. Okay. The equation is 5 power x, and again you have been asked to solve this equation, and whenever the examiner would ask you to solve any equation, that certainly means you need to find the value of x. And when it is about finding the value of x, it basically means you need to make x the subject, but this time around x is in the power. So how do we simplify this? By taking log on both sides. So simple log 5 power x and then log 3 power 2x plus 1. Okay, then I know this is a property for logs. This x and this 2x plus 1 would come over here, and this would come over here. So I can write it as x log 5 equals 2x plus 1 into log 3. Now the next step would be, I can simply just see I am almost done. I'm just left with this part. So I am going to expand it. This is x log 5 equals 2x log 3 plus log 3. I am going to take it on the other side. It would become x log 5 minus 2x log 3 equals log 3. Now I can take x common just so it is there. I can make x the subject. And now I would have log 5 minus 2 log 3 equals log 3. Now if this comes in a paper where calculator is allowed, you can certainly just, simplify it, find the answer. So we are going to just simplify it. It would become x equals log 3 divided by log 5 minus 2 log 3. Now, certainly we cannot cancel anything. We cannot simplify it directly. You need to have your calculator at this point, and after using the calculator, the final answer should turn out to be minus 1.89. So this is going to be the answer. So it's not necessary that you would be able to cancel logs and get a proper answer by using the log properties. No, not necessarily. Yes, if that happens, fair enough. But otherwise, you can certainly come across questions where you are not able to do so. Okay. All right. So let's talk about another question now. Okay. So the next example says, now the difficulty level would obviously increase gradually. Example number 3, solve the equation log 10 2 plus x equals to plus log 10 x. This is the question that we need to solve. Okay. Now, in order to understand this properly, let's see how to do it. Okay. Okay. Now you have log everywhere, but we do not have a log with 2. So in order to do this properly, we need to have log with 2. And I know that log 10 10 is going to be 1. So I can directly add log 10 10 over here, and that would be equivalent to 1, and I can certainly multiply a number with 1. This means it would become log base 10 2 plus x equals 2, and with this 2 I'm multiplying 1, and I'm not writing down 1, I'm writing down log 10 10 because I need log with every number to simplify. Log 10 x. Okay, next what I need to do is I can directly just take this 2 over here, and it would become log 10 2 plus x equals log 110, because it would become 10 squared, and 10 squared is 100, plus log 10 x. I know that when I have two logs which are being added, I can write it as a product. So it would become log 10 2 plus x equals log 10 into 100x. Now what's the thing? We have an equality sign and the base is same. We have log on both sides. What does this imply? This would imply that this and this, they are equal. They are also equal. So this implies 2 plus x is equal to 100x. And now I'm just supposed to simplify it. So this would give me 2 equals 99x, and this would give you x equals 2 by 99. So this is going to be the answer, and this is certainly correct. So this was the third example where we basically had log in the question, and we had log with every term except one term. So I can multiply any term with 1. If I can multiply a term with 1, that certainly means I can multiply that term by this as well. And when I multiply the term by this thing, I had every term with log base 10. I've used some basic log properties. We had plus sign here. So I multiplied these two numbers, and at this step, or at the third step, what I had was basically log on both sides. The base was same and they were equal, which meant that 2 plus x would be equal to 100x. And then by making x the subject, I got the value of x, that was 2 by 99. So this was all about the equations involving log in it, and some of the equations did not have log in them, but in order to simplify those, we had to incorporate log. Okay, but if you remember, in the title I wrote it is basically about the equations and inequalities using logarithm. So let's talk about the next part of this unit, that is inequalities. Okay, all right. So example number 4. Now it says solve the following inequalities. This is the question. Okay. Part A says 5 power x is less than equal to 13.3. All right. Now again, such questions are obviously going to come in the calculator exam. We only have calculator exam in A2. So for this one, we need to solve this inequality. Whenever I've been asked to solve an inequality or an equation, the idea is same. I need to make x the subject. And for that, I need to just take log on both sides. So log 5 power x is less than equal to log 13.3. And again, this x can basically come over here. So it would become x log 5 less than equal to log 13.3. And I am going to get x is less than equal to log 13.3 divided by log 5, and I am going to get x is less than equal to 1.608. Now, certainly I did not calculate this using my knowledge or, just orally by cancelling out something. No, I had to use calculator for this one. We are not that players with the decimal numbers. So it's completely fine. Some of the questions would certainly be solved using calculators. And I skipped one of the sections where you only had to use your calculator. So this is how it is, right? Okay. All right. So this was the first part. Let's talk about the next part of the same question. Okay. Part B says 0.4 power x is less than 0.0001. All right, okay. This is what we have, okay. Now, in order to simplify this is x. I can just take this x over here by taking log on both sides. So again, step 1 is log 0.4 power x is less than log 0.0001. Next, this x would come here and it would become x log 0.4 is less than log 0.0001. And after simplification, I would get x is less than log 0.0001 divided by log 0.4. Now I'm not supposed to do anything on my own. I'm not supposed to use my calculator and then do it. I am just directly going to use my calculator. So it is log 0.001 divided by log 0.4, and this is going to give me x less than 10.1. So this is going to be the answer. Whenever x would be less than 10.1, this would be the situation. Okay. Now at this point, this is what we are getting as the answer, right? But let's take a number less than x. Let's say this is how we check actually. Let's say x is 9. So if you do 0.4 power 9, this would give you 0.00026 and so on, right? So it would be 0.0. Let me just write it down again. It's 0.000262144. Okay, this is what we would have. And now we can certainly see that 0.00026 is greater than 0.0001. This means that this answer is not correct. This is not correct. So it is other way around. It would basically be that x is greater than 10.1, and then it would answer your question. Basically, for such questions and even for quadratic inequalities, we usually refer to graphs, and we usually do it that way. But this time around, since we did not discuss the graphs and we wanted to keep things clear, the best strategy is, if you are getting this as the answer, just try taking any value, plug in that value, and if that does not satisfy, just use the opposite sign, and then that would be the answer, right? All right, okay. So this is what it is, right? And if I explain the logic behind it, the logic is just this, that here we had 5, so it was basically monotonically increasing. Since 5 is greater than 1, here we have 0.4 and it is monotonically decreasing because 0.4 is less than 1. So that's why it's other way around. We just change the sign. So just know, whenever you would be having a decimal number over here with this x, yours, if this would be the sign, for the final answer, the sign would be changed. Okay, you can use this way, you can use the graph method, you can just plug in this one and check, and if your answer is wrong, then you can change the sign. So you have multiple ways of doing this question, right? Okay, all right. Let's talk about another question now. This question says, this is example number 5. Solve the equation log 10 2 minus x minus 2 log 10 x equals 1. This is the question. Okay. Let's talk about the solution of this one. So we have log again, and you've been asked to solve this question. And for solving this, we need to get rid of this log. And how do we do that? By having log with every term. So we have log with the first term, we have log with the second term, but we do not have log with the third term, that is 1. How do we have log with 1? We know that 1 is basically equal to log base 10 and 10. So I can write it again as log base 10 2 minus x minus 2 log base 10 x equals log 10 10. Okay. Then I can just take this 2 over here in the power of x and I would get log 10, 2 minus x minus log 10 x squared equals log 10, 10. Next, I have a difference here. I can just write this entire thing as 1 log and it would be written as log base 10, 2 minus x divided by x squared, and that is equal to log 10, 10. Again, the situation is same. We have log 10 on both sides. We have log 10 on both sides. And we have an inequality sign. So I can directly say that these two entries are equal. If these two entries are equal, then this would become a quadratic equation. I can write it as 2 minus x by x squared is equal to 10. And I can just take x squared on the other side, and this would give me 10x squared plus x minus 2 equals 0. This is my quadratic equation. And again, here we are not discussing quadratic equations. We know how to simplify this. And after simplifying this, I would get x equals 2 by 5. And I would get x equals minus 1 by 2. So again, we're getting two solutions. Are both these the solutions? No. We cannot have a negative number here. Why can't we have a negative number here? Because if we have negative 1 by 2, I would be having negative 1 by 2 here as well. And I cannot have negative number in log. Just try doing it for now. Take log with any negative number and you would come across an error. Okay, so the only answer would be x equals 2 by 5. This is going to be the answer. So this is how we do such questions. So in this video, we had a detailed discussion about logs, about logarithmic equations, about logarithmic inequalities. In the very first example, we did not have log directly, but method 2 basically was all about using log in order to solve the equation. And we know what happens when we apply log. When we apply log, the power is basically multiplied on the other side, and then we are able to make x the subject. And then again, this did not have log initially, but in order to solve this, we had to take log on both sides. And then by simplifying, we got x as the subject. We were not able to cancel logs over here. And this can certainly happen. So we just used our calculators and we ended up getting negative 1.89. Then the next example was a bit tricky. We had 3 terms. That was basically an equation. All the terms were with log except one. So we added log using this idea. Please don't forget this. This is very, very important. And this is how we are going to do questions in exam as well. Okay, you will see in past papers, this idea would be used again and again. And this is where we incorporated it. We only had 2 here. I know that I can multiply 2 by 1. So instead of writing down 1, I've written this thing. And then I made x the subject and I got this as the answer. Then it was an inequality. I was able to solve it and that is perfect. An important thing about inequalities was since we had a 5 here, so whenever we have 5, whenever we have a number greater than 1, this sign would remain as it is. But if we have a number that is less than 1, then the sign would be changed. This was the sign initially, and in the answer this would be the sign. Okay. And then for the last question, it was again easy. Every term had log except this one. And we know how to write down 1 as log. This is how we write down 1 as log. So we have just done that. And I got a quadratic equation out of it. And just by solving, I got 2 values. Negative values cannot be used for logs. So I ignored this value and this is going to be the only answer. So I hope that you guys were able to understand the concepts, understand the idea behind these questions. In case of any queries, any difficulties, feel free to ask me. You can use the link in description to get yourselves enrolled for our live classes where we cover the entire syllabus and we practice a good number of past paper questions. So that is it. Then I will see you next time in another video. Take care all of you and Allah Hafiz.